Hey guys. So I did a video the other day here, which is the one here that's on screen, and it's part 32 in our Let's Make an MMO in UE4 series, and I talked about multiplayer sprint being impossible in blueprints, and that you can't directly set the max walk speed even though it lets you do it in multiplayer. And so I was showing how in our Let's Make an MMO in UE4, how we were using the character movement component, and we had created a start sprinting and stop sprinting. And but in that series, in Let's Make an MMO in UE4 series, we only look at blueprints. We don't look at C++. But a lot of people had asked me. They said, "Hey, I'd really like to know how the C++ works, because you did sprinting there, but I want to do a dodge, or I want to do a leap." There was someone in the comments who talked about using launch, which we'll be looking at here today. There's a lot of other movement related. Now, when I say movement related, I mean that you're moving the capsule. You're moving the capsule around the player. Again, all of this only applies if you're using the character. If you're using a pawn, you don't get the character movement component, and none of this applies. So if you're tuning in and you normally watch the Let's Make an MMO in UE4 series, we're not going to be touching that project today. So we're not going to make any changes to it. I'm not even going to open it. And if you're not interested in the C++, you can skip this one. But if you are interested in the C++, we are going to take a look at it in a brand new project. So open up Unreal 4.22, and we're going to go to BP, third person. Call it test. Now let's see, custom CMC, character movement component. Create a project. You will need Visual Studio installed. I'm using Visual Studio 2017. Haven't upgraded to 2019 yet. It's on my to-do list. First thing we do when you're going to get in here, run dedicated server from the play menu. Everything that I do only works on dedicated server. I don't mess with listen server and the peer-to-peer stuff at all. So if you're doing that, I have no idea if this will work or not. I only been doing it for 5 years, and I only do dedicated server. I don't even know how to do single player in UE4. Okay, so first thing we're going to do is we need to create some C++ classes. And first we need to create a character. I'm just going to take the default my character. And it's going to build this for us in Visual Studio. Hopefully it won't take too long. I will be copying pieces of code today instead of typing them, so that I have more time to talk about what they do rather than have to sit there being careful to make sure that I type everything exactly perfectly. So I'll be copying one chunk at a time, and then we'll talk about what it's doing. The first thing that we're going to have to do here is we're going to have to get our character movement component hooked up to our character, cache a reference to it so that we're not having to use casting every time. So that's going to be one of the first things that we do. But let's get both of these created first. So I'm going to come back here, new C++ class. We're going to do show all classes. Character movement, there it is, character movement component. We're going to take the default my character movement component. And we're going to create that class. Okay, so we've got our 4 files here. And we're going to go to the header file for my character. Okay, and we need to modify the constructor here. So we have to send in this parameter because we need to use this object initializer they have a way that you can set inside the character that we're inheriting from here, you can set the movement component. So it's kind of a cool method, but we need this object initializer to do it. Then we're also going to need this function. And what this is going to do is it's going to create a BP node called getMyMovementComponent. And this will give us a movement component that is already in my character movement component. If we don't do this, which you don't have to, every time you want to grab this, you'd have to get the normal character movement component, cast it to my character movement component. We don't want to do that. We want to cache it and just return the value here, right? It's just going to be this variable. So you'll notice here that it's, let's see, okay, that went away, good. I'm actually surprised it was able to read that. So we actually need to add the header for the my character movement component. Normally that would stay underlined to tell us that. This one here is complaining for good reason. We need to put a reference, get ourselves a private reference here. Here's where we're going to cache it. Okay, so we're going to cache that. And we're going to cache it in post-initialized components, which this method here is going to get called after all the components are created, meaning we know it's done and the reference is good. We're going to save it here, and then anytime we call this blueprint node, we're just going to return it. So nothing too complicated here. That's the end of that file. We're going to go to my character. Okay, there's a few things we promised to do here. We promised that we would give it a different constructor. So I'm going to dump this one and paste in here. So remember, it had this, right? So we added that. And the object initializer now lets us call this set default subobject class. We set it to our type. And this is just kind of an identifier that's in that A character. There's a couple other things you can swap out too. You can swap out like the component. I think it's all of the main things they build for you in the character, like your collision capsule and all those can be swapped out. So anyway, this is how you do it. And we're swapping it out for ours. We're saying don't use character movement component, use my character movement component. Then we also promised, see this here is just a promise. We promised that we would override post-initialized components. I'm going to copy that over. You may have to stop the video at certain points, to copy this down. Maybe I'll put the project. There's not going to be any assets in this project, so I can probably put the project. I think I'll do that. When I get done, I'll zip it up, and I'll throw a link to it too. So you can copy and paste rather than sitting here typing in every letter, which isn't fun. In the programming world, we copy and paste. We don't type. Okay, so our character's pretty good, and we're actually going to start this thing up so I can show you what it's doing, what each part's doing, rather than all of them at the end. Hopefully this won't take too long. Empty projects load up so much faster than real ones. Okay, so what I wanted to show you is that over in the blueprints, because of what we've done, okay, so this blueprint is inheriting from character. We need to go into File, Reparent Blueprint. We need to reparent it to my character so we get our extra functionality. And we've done that. Well, that's very strange. I still had it open. No, that's my other one I'm copying from. Okay, that's really weird. I gotta try to see why it thinks it's open. So I am... Oh, yeah, we got it open twice. Sorry about that. Not really sure how we did that. Don't save is fine. I guess I still had it open. Oh, because I know why. I had it open. Yeah, I didn't close it. My bad. Anyway, I had it open from... I'm not used to using the launcher. So this Epic launcher thing here, I don't use that. So I was really confused because it was open. I come in here and build it and always run it from here. So then I can only have one open at once. So sorry about that. Start it back up. It wouldn't let me save it because the other one had a lock on it. Okay, do it again. Back into third-person character. Its character is the parent class. That's up here in this top right. I'm going to reparent it. My character. It's going to save this time. And when we do that, notice that my character movement component, right? So we're no longer using character movement component. We're using my character movement component. And now we got to go build that. So I'm going to close it down this time rather than what I did last time. And we're going to move over to our character movement component. Okay. So the best way to think about this is that there's a movement queue, okay? There's a move queue in this character movement component. And everything that you do movement related has to be put in the queue. If you don't put a move in the queue, then it doesn't work, right? It's like you're hacking your own game. You got to put the moves in the queue. But to do that, we have to build our own moves. And so that's what we're going to do here. So first I'm going to go and switch this to generated uClass body, because I'm going to have a constructor, even though we're not going to use it. And I'm going to copy in our move. Okay, and I'm just going to put this class for simplicity right inside the other class. We could give it its own file and put it in separately, but I'm just going to put it right in here. I believe Epic does the same in Unreal Tournament. All this code I'm showing you comes from Unreal Tournament. This is how they do it, and this is where this code comes from. So we are going to create, there's this saved move character, and this is this base structure, base class, for the moves that go in the queue, right? So they all inherit from this saved move character, and they probably have a base class below that. I didn't check. And we're going to build our own queue. I just did fSavedMove underscore, and I just called it my, You could call this like the name of your game or the name of this character movement or whatever you want. This is our move. And so we got to do a few things. First of all, we want access to super, so we're going to type def that. And we're going to override some functionality. Okay, so we've got this can combine with. This decides what moves can get combined together and sent together at the same time in the same network packet. This just sets the move back to defaults. Get compressed flags. I had showed in the other video, if you looked at it, I showed that there's this uint8 with 8 bits, and there were custom flags. The first flag that they used was jumping. The second flag was crouching. 2 were reserved and 4 were custom. We're going to use 2 of the custom ones today. This set move 4 is basically taking the values from our character movement component and putting them into this move to basically build this move. And the prep move 4 is, so this is a flag for requesting a walk speed change. This is a flag for dodging. But we're going to use prediction information on the move direction. Prep move 4 is going to take care of that for us. So there's our move. We also need some prediction data. So here we go. So this one here, we're not really doing anything special. Again, it inherits from this F network prediction data client character, and all we're using it for is to allocate our move. It's going to allocate the move of type this, of this special type here, fSavedMove underscore my. Okay. So we've got those 2 classes set up. We're going to create a public section here, and we're going to start adding a few things. Okay, so I'm going to actually add that one later. Yeah, I'm going to add that one later. Okay, inside our movement component, remember that I said here that we use setMove4 to take the values from the movement component and put them in the move? This one here kind of does the same thing in reverse from the compressed flags. These uint8s are what get put in the compressed flags. We've got our get prediction data client. This just sets up some of the settings. We're going to be setting some of the network prediction settings in this one. I just copied the default values from Unreal Tournament. You can play around with them in your game. On movement updated. This is what's actually going to do our movements for us. So this thing here is going to look to see if these flags have been flipped, and then do something, and then set the flag unflipped. So that's where we're going to do our dodge and where we're going to do our speed change. If you try to do it somewhere else, you end up with net corrections. So that's the place that's able to do it without trouble. Okay. This is our code for setting max walk speed. So this is our, so remember we have one up here, saved request walk speed change, but that's in the move. That's in the move queue. This is the one we'll set in this movement component to tell the whole thing to start happening. Now, when we do that, we need to send a piece of data. And the piece of data we're going to send is the new max walk speed. So we need this replicated, unreliable, with validation, server underscore. That's what I use to do a run at server RPC. That's just the way I name them, server underscore. Makes me always remember what they are. I have owning client ones for going back to the owning client, and multicast underscore for the multicast, which I don't really use multicast, but okay. So then this is our walk speed, the new one, my new walk speed. If you actually try to set it directly without going through this intermediate one, it completely defeats the purpose of doing this, and you still get the net corrections, which is the whole thing we're trying to stop. And then this is our blueprint function. So we're going to build a blueprint function called blueprint node called set max walk speed. This runs on the owning client. You don't have to call it on the server. It automatically replicates up to the server for you with this. And there's the walk speed we're setting in. Okay, for our dodge, we are going to have a dodge strength. And this is basically the velocity multiplier. I use 10,000 as a default. We got to make sure we go set that in the blueprint when we get that set up. Same thing here. When we do the dodge, we have to tell it what direction, a movement direction. It's sitting here. We use a run it server RPC to send it. And this do dodge, I actually don't like it called do dodge. Fix that. I just like dodge. This dodge here is going to be what we call in blueprint to do our dodge. And again, it runs on the owning client and it replicates up automatically. Our movement direction internally, and the flag will flip that says, hey, we want to dodge. Okay, we're moving on to the CPP. I gotta remember there is one thing I didn't do, but I'm gonna let it do it wrong first, and then I'll come back and fix it. Let me see if there was any. We're good on our headers. So let's go to our CPP file. Okay, first off, we promised we would have a constructor. There it is. I think I'm going to do this. I didn't do this in the test project, but I'm going to do this anyway. So dodge strength, I'm going to set it equal to 10,000. This will make sure that it'll be set as a default in Blueprint, and I won't forget, which I've forgotten in the past. So, okay, on movement updated. Okay, so we're overriding this on movement updated. It's in the base character movement component. We check to make sure that there's a character owner. If not, we return. This one is for set max walk speed. So we basically say, hey, did someone request the max walk speed to change? Okay, first thing we do, that means this is true. First thing we do is set it back to false. We only want this to run once. This code will run on the owning client, followed by running on the server. Okay, so then if we set this max walk speed. Let's see here. Yes. So this max walk speed, that's the real walk speed in the character movement component. That's the one that people are setting directly in Blueprint that causes all the issues. So we're actually setting it here based on the my new max walk speed that we've previously pulled in. So right now this probably doesn't make any sense because you're not seeing how these, you're not seeing how the values get there, right? But this is the end result. We're kind of doing it backwards. This is the end result. The end result is to do this that we're showing right here. Same thing with the dodge. We want to dodge, okay. Flip it to false so it only happens once. There's some weird things happen with the in-air. I'll show you. This actually isn't perfect. There's a better way to do this, but I said, you know what, for this demo, let's only dodge if we're on the ground. Which technically you shouldn't be able to dodge if they're in the air anyway, because once you are up in the air, but I know, there's all different kind of games. So we have our move direction, we normalize it, so we'll get a unit normal with a length of 1. We then multiply that by the dodge strength to get the dodge velocity. We do not want to dodge up. So we take the Z component, we zero it out, MNU's launch. That's the same launch that you see in blueprints. That's the same one that you call. So again, this is running first on the owning client, followed by replication up to the server, followed by going on the server. And since it's all going into the move queue, it's all predicted, it's all handled, it's all smooth, and we have no issues, even under high lag, up to a point. Okay, I'm going to skip the next one because we're skipping that. So, okay, here we go. Update from compressed flags. So this is the one that takes the value out of the saved move, right? So here's the saved move. It's in flags here. It's getting the flags from it, and then it's pulling out these values, and it's putting it into request and wants to dodge. Okay, so that's just getting the values out of this compressed flag, which is just an 8-bit number, 0 to 255. Okay, this one here is for getting our prediction data client. It's something we have to override to get this to work, and so we're basically setting this prediction data here, and we're doing max smooth update distance is 92 centimeters, no smooth net update distance is 140. So this is setting how far you can be off between the client and the server before it corrects. Some people may adjust these numbers. I think these were the ones in Unreal Tournament. They seem to work well for my test. I'm not gonna dispute them, but if you need to adjust them, that's where they are. Okay, here's our clear. Notice now that we're not in the movement component anymore. We're in the saved move. Okay, so this is the saved move, inside the move, in the move queue. We call the clear on the super, which is the base class, and then we set them to the default value, false, false, 0 vector. Yep. So then get compressed flags. So this is also in the move, and we're saying here we're building up this result, right? This is what we're trying to return. We're trying to compress these flags together, and we're basically saying, we're ORing the bit into it. 0, I don't know, each one of these is a bit. I don't remember which bit 0 is. It's probably the 4th or 5th one. It's the 5th one, but I don't remember if it starts from the small side or large size. Anyway, and then flag custom is this other bit, and we're basically just ORing those into the result and combining those together inside the move. But then, of course, there's rules on combining. For simplicity, I have set that none of the moves can combine together. So, in reality, you may be able to combine some of this stuff together. But I just said, you know what? Nope. We're not combining anything. Okay, set move 4. Okay, so we're taking the values from our character movement, right? We get it here. Character was a reference. We get the character movement. We cast it to our type. And we're taking the values and we're putting them into, these are the values in the saved move. And so we're putting the values into it. Prep move 4. So we're taking the saved move direction, and we are putting that, we're prepping the move here. So we're taking the saved move direction, and we're putting it in the character movement. Okay, now we're into this client, prediction client. There's that empty constructor because we said generated U class. Okay, now we're going to start, let's see here. Oh, no, there's one more. Got to allocate the move. And here's our allocate move, and we create it of type fsaved move my, right? So this just gets it to use our type. Otherwise, it was going to use the base original type. Okay, so at this point, we're going to start moving on the max walk speed. And as you can see here, we have, this is the server. This is the validate and the implementation. Anytime that you set this reliable or unreliable here and you make this a RPC, if you use with validation, then you have to have an underscore validate on the end. And if it's a replicated variable, or if it's a replicated function RPC, you have to do this underscore implementation on the end. So what we're doing here is I'm saying, hey, if the client tries to send you a walk speed, make sure that it's not less than 0, and that it's not greater than, and this can be whatever your maximum speed in your game would be. I'm saying 2,000. It's pretty high. So if somebody tries to send something outside that, this can be used to stop hacking, to some extent, because they can still hack within that range. They just, anyway, it validates what they're sending. You could check other things too. You could make this more complicated and be like, well, they're trying to change the walk speed, but the walk speed's part of a sprint, and the sprint has to have a certain amount of energy to execute or something like that. You could check all those. Return false if it's not supposed to happen, true if it is. All we're doing here is taking that new max walk speed and putting it in our temporary my new max walk speed so that we can use it later. This is our blueprint function. So set max walk speed is going to be the name of the blueprint node. We send in the new max walk speed. We make sure that this is locally controlled. And if so, we take the new max walk speed. This is on the other side. Take the new max walk speed from we're sending here and put it into this one on the client. And then this is what calls this and replicates it up to the server. Okay, now we're going to do our dodge. Again, same thing. There's no validation on this dodge. I'm just saying return true. I don't know what I'd validate. Not sure. The movement direction, we're already zeroing out the Z, so it can be any direction in the XY plane. I don't know. I don't know what you'd validate. And here we take the move direction we're sending in, and we put it in our temporary move direction. And finally, we have this here, which we're going to change the name to dodge. And we're getting the last movement input vector, right? What direction were you moving? The input vector. And basically meaning not which way are you moving, but which was the last input vector. So that would be arrow keys, or I've also tested this with my gamepad sitting here. So, and then we're going to take that value, replicate it up to the server, and we're going to call once to dodge. Okay, we're going to run this, and there's a little bit of a problem with it, but we'll come back and fix that. It's just a problem with the dodge. It's a simple little thing. And I'm not surprised. We changed a couple. Oh, yeah, you know what? I had this issue too. So, for some reason, it needs our to know our character here with the H, which is odd because it's a character. I don't know. That one's odd, but this fixed it. Okay, so Blueprint's going to be real simple. That's one of the great things about this. We're going to do almost nothing in the Blueprint. So first I just want to show you that it pulled in that 10,000 on the dodge strength. Otherwise we'd have to set that. So we're going to come here. I'm going to use left shift, and I'm going to use left control. Okay, for the sprinting, we're going to get my movement component. See how easy that is? No casting. Set max walk speed. Create another one here. The default walk speed in this project is 600, so when you let off, I'm going to return it to 600, and I'm going to do 1200. And I'm going to connect that. So now we got our sprint. And for our left control for our dodge, this one is even easier. Just going to do once. And say, get movement component. We're just going to type dodge. That's it. Nothing else. All the replication's taking care of it for us. Run dedicated servers on. Okay. So I hold down shift and I definitely run faster. Okay, that's cool. And I hit control. Oh, I gotta be moving. Okay, see what happens? It does the little thing that it does the hop at the end. So here's why. The built-in launch, it changes your movement mode to falling. So that was the thing I was saying I wanted to show you. Otherwise you wouldn't understand why we did what we did. So I'm going to come back to my movement component here, and we're going to override how it handles the launch, which they make super easy to do. Handle pending launch. So we're going to override that, and then we're going to come down and grab the code here for it. Right here. So this was the original. And all I did was just rem out set movement mode move falling. It was that simple. I just this right here was copied and pasted right out of character movement component, and I just went and said, oh, you know what? I don't want it to switch to movement mode falling. I tried before launching and then switching the movement mode back to walking, but it didn't fix it. So I said, okay, I'll just override it. So that'll fix it. So now, see, it does like a quick dodge, you know, thing. Anyway, it's using launch. You could, if you wanted this to do like a big giant leap kind of launch type thing, you know, where I said, hey, let's set the Z value to 0. You could always set the Z value to some positive value to get it to jump up in the air, and then don't override that handle thing. The handle pending launch, so that it does actually do the falling mode, which is probably what you'd want if you were leaping. So there is one problem with this. I'll show it to you. It's that if you leap, so we're having to make that value 10,000 so large to counteract the ground friction, which is not ideal, because as soon as you are off the ground, you see it just goes flying, which is not ideal. So what I would recommend it if you were really doing a move like dodge move like this in a game, is to just turn off the ground friction. Don't use a huge number like 10,000. Use a meaningful number, which will be a whole lot smaller once the ground friction's gone. And then after a certain amount of time, probably you'd have to determine what's the end of your move, which would probably the easiest in this type of situation would just be a certain amount of time. Then turn the ground friction back on. So that would be a better way to do it. Otherwise, you'll get that. But there we go. Now we can change the max walk speed. And here was the goal. P.net show corrections 1. So we're running. If I were doing this with the blueprint method where people change the walk speed, I'd have capsules popping up all over the place. Same with this dodge. This dodge would be horrific. It'd be bouncing, the screen would be bouncing all over the place. Jitter everywhere. Net corrections everywhere. Okay, but that was with no lag. Let's give it some lag. And here we are. Doing our running around. Now you can occasionally get them. I get them sometimes by like slamming into an object really hard or something. That's not the same as it doing it every time you activate. So that's actually, you know. So you normally want to not see those net corrections. They're costing you. And they cause jitter and bad gameplay and probably extra network overhead. We don't want those. But if you see one from like, see, there you go. See, I slammed into something and it created one. That's normal. That's what it was intended to do. But you don't want to see it when we activate. When we activate our abilities, when we like let them on and off, that's where you don't want to see it. That's bad. And there you go. So you can use this method to create any kind of character movement you want. If you're using the gameplay ability system, you can call these from the ability system. There's a lot of things you can do, but this is the proper way to build anything that moves the character capsule, which is what those things are showing here. That's just an outline of my capsule. This is the proper way to move the character capsule within the character movement component. So you need to be doing this anytime you want to make a movement ability for a character. If you're using a pawn, this doesn't apply to you. But if you're using a character, this is the only way to not get network prediction. If somebody knows of another way, let me know. But I've tried every method on the internet, and this is the only one to where you can reliably not get net corrections with P net show corrections on and some amount of network lag, like 100 milliseconds. So if you have any questions, let me know. See ya.